Alright everybody, today we're going to take a look at solving quadratics using the square root method. Alright, so I can use this square root method when there is no x term, or we could say there is no b term. Okay, now what is the b term, right? Let's think back to our standard form, ax squared plus bx plus c. So there is no x term, there is nothing in the middle of that quadratic. So we have ax squared plus a constant at the end. There is no b term. We can solve using the square root method. So there are two steps to solve using the square root method. The first step is to isolate for x squared. Once you have that, then you're going to take the square root of both sides. So example number 1, we got x squared minus 64 equals 0. So step number 1, we need to isolate for x squared. So I need to move this minus 64. Again, the way I move something in math, inverse operation. So the inverse operation of a minus 64 is to add it to both sides of my equal sign. That goes away. We've got x squared equals 64. Next step is then to take the square root. So I'm taking the square root of both sides. Well, the square root of x squared is x, so x equals the square root of 64. Now, once again, we can break down the 64 into 8 and 8, so we have factors of 8. When I get a pair, they come outside the house, they become one couple outside. Okay, so I have 8 outside, nothing left underneath, so my answer is x equals 8. Now, the biggest thing that we need to know is that x is going to be equal to what we say plus or minus 8. Okay, plus or minus 8. And what that means is that x is equal to a positive 8 or x is equal to a negative 8. So you have two answers. You have two answers. Okay, we could write it as x equals plus or minus 8, or we could write it as negative 8 and positive 8. Both answers are correct. Right, and so let's think back to what we're looking for here. When I'm solving a quadratic, I'm looking at the roots or the solutions. And again, that is my x-intercept. So what we just found is that my quadratic, my parabola, crosses at negative 8 and positive 8, plus or minus. Okay, negative 8 and positive 8. So your x-intercepts are at negative 8, 0, and positive 8, 0. So again, this is the biggest thing that we are learning new today. It's a plus or minus 8. Okay, plus or minus. So x is a positive and a negative. Alright, let's go to some more examples. Number 1, x squared minus 81 equals 0. So I want to add 81 to both sides. I get x squared equals 81. Last step is to take the square root. So I get x equals plus or minus 9. Okay, once again, plus or minus 9. Because 81 can be broken down into factors of 9 and 9. Once I have the pair, they come outside. They become one couple outside. Number 2, same thing. I want to isolate for x squared. So the first step is going to add 200 to both sides. That goes away. I've got 2x squared equals 200. Still haven't isolated for x squared. Now I need to divide by 2 to get x squared by itself. So I get x squared equals 100. Now once again, I'm going to take the square root. So the square root of x squared is a positive x. So x equals square root of 100. That's a perfect square also. So plus or minus 10. Same thing here. I want to isolate for x squared, so I'm going to divide by 4. X squared equals the square root of 25. Sorry, I'm a step ahead. X squared equals 25 over 4. Now that doesn't divide evenly, so let's leave it as a fraction. Second step is to take the square root. So I got x equals the square root of 25 over 4. Now let's think back. I'm going to take this as the square root of 25 over the square root of 4. Okay, well the square root of 25 is a perfect square, and that's 5. The square root of 4 is a perfect square, and that's 2. So the square root of 25 over the square root of 4 is equal to 5 over 2. So x equals, once again, plus or minus 5 over 2. Same thing with number 4. I'm going to divide by 3 on both sides. X squared equals 9. Take the square root. I get x equals plus or minus 3. Divide by negative 2 on both sides. I get x squared equals 144. Take the square root, and I get x equals plus or minus 12. Last one on the front, I'm going to add 7 to both sides. That's going to be x squared equals positive 1. Square root of both sides, x equals, square root of 1 is, you guessed it, 1. So plus or minus 1. All right, let's go to the back. More examples, right? Now let's look at some of these. Let's look at number 7, okay? And I'm going to point out number 7 for a reason. First step, I want to isolate for x squared. So my first step is to subtract 8 on both sides. I got x squared equals negative 6. So once again, we're going to take the square root of both sides. So x equals, the problem is you cannot take the square root of a negative number. There is no real solutions. So anytime you are taking the square root of a negative number, there are no real solutions. No real solutions. Okay, so what that's telling us is that my parabola is not touching the x-axis because there are no solutions. There are no x-intercepts. There are no real solutions. Okay, so anytime you have a negative number underneath your radical, underneath your square root sign, no real solutions. No real solutions. No real solutions. All right, let's do one with a fraction. So the way I get rid of a fraction is to flip it and multiply. So I'm multiplying by 2 on both sides. That goes away. I've got x squared equals 36. Take the square root of both sides, and I get x equals plus or minus 6. Because again, 36 is a perfect square. All right, let's look at number 9, because number 9 is not going to come out even. All right, so again, 5 times x squared. I want to isolate for x squared, so I'm going to divide by 5 on both sides. X squared equals 100 divided by 5, which is 20. So now, next step, take the square root of both sides, and I got x equals the square root of 20, plus or minus. Now, we're looking for factors of 20, right? 20 can break down into 4 and 5. You don't have a pair, so keep breaking down till they're prime. 4 breaks down into 2 and 2. So you've got a pair of 2's. They come outside. They become one couple outside. So I can reduce this radical to x equals plus or minus, x equals 2 plus or minus the square root of 5. Or I could say x equals plus or minus 4.47 if you put it in your calculator. These mean the exact same thing. You do you, boo-boo. You do you, boo-boo. Okay, let's look at one more. Let's look at number 10. Number 10, I want to add 140 to both sides. So I got 2x squared equals 140. Next step, isolate for x squared. So x squared equals 70. Once again, we're going to take the square root of both sides. So 70 breaks down into 7 and 10. 7 doesn't break down. 10 breaks down into 2 and 5. No pairs. So we're going to leave it as a square root of 70. So I could say x equals plus or minus the square root of 70, because that does not break down. Or I could say x equals plus or minus, if you put it in the calculator, you would get 8.37. Alright, so now let's look at a word problem that involves our square root method. Alright, so we have what we call the falling object model. So this is what we denote as basically gravity, right? The equation for gravity. Negative 16t squared plus s is equal to h. Okay, now what is h, what is t, what is s? H is ground level. T is obviously time, right? T stands for time. H stands for height. Okay, and then s is going to be your initial height or your starting height. right? So if a rock is dropped 30 feet above the ground, my initial height would be S. All right, so looking at number 13, it says Sarah drops an egg from a height of 42 feet off the ground, right? So that is S, initial height of 42 feet. How long time does it take for the egg to hit the ground? So I want to know T, how long T does it take for the egg to hit the ground? Okay, well this hitting the ground is ground level, right? So H. Well, I know ground level is 0. I want the height to be 0. So let's set up our equation. The height, or ground level, 0, is equal to negative 16t squared. I don't know what t is. I'm looking for it. How long does it take? But I know the initial height, the 42, can go in for s. So plus 42. Now we're going to solve for t, right? So we're going to do it just like we did up here. Just like we did up here. We're going to isolate for t squared. So I need to move this 42. Negative 42 equals negative 16t squared. Now I will need to isolate for the t squared, or the x squared. So I'm going to divide by a negative 16. Alright, so those cancel out, and I've got a positive number. So t squared equals, what, 2.625 or something like that? Now I'm going to take the square root to get t by itself. So t equals plus or minus 1.62. Okay, so what we just figured out is it's going to take about 1.62 seconds for it to hit the ground. So about 1.62 seconds. Alright, now that doesn't make sense, right? Okay, let's do another example. Ella is walking across the bridge and accidentally drops her watch. Don't drop it in the water. Holy cow, especially not an Apple Watch, right? Oh my gosh. Poor Ella. Okay, it says the bridge is 80 feet above the ground, or the water, excuse me. So the bridge is 80 feet above the water, initial height S. Again, how long does it take? So I'm looking for T, for it to reach the water. Well, we know the water is ground level, in quotations, so 0, again we're plugging into this formula, is equal to negative 16t squared, but now my initial height is 80, so plus 80. Again, we're going to do it just like we did on number 13, right? So I need to get t squared by itself, so subtract 80 on both sides. Negative 80 equals negative 16t squared. That's 16 times t squared, so we're going to divide by a negative 16 on both sides. So I've got t squared equals square root of, what is that, 5, right? So now, once again, I want to get the t by itself, so I'm going to take the square root. So t is equal to plus or minus the square root of 5. Now, square root of 5 cannot be broken down, so you could leave it as that. That's a correct answer. Or we could plug in the calculator and say that's about 2.24 seconds.